Okay, welcome. We're about to start. You can share the link with your friends. We're about to start. You can share the link with your friends. We're about to start. This session is not going to last for long. I think in the next 4 to 5 minutes we should be done, and we climax, then we begin another time. All right, I can see Louis Vic. You're welcome, Louis Vic. All right. So if you are currently active, drop a hi on the comments. I want to see that. All right. So in the next 3 minutes, we'll be commencing. In 3 minutes, time, we'll be starting. So share the link with your friends so they can join us. All right. Hi, I can see Joel Okon. That's beautiful. You're welcome, Joel Okon. All right. So in the next 2 minutes, we'll be beginning. So you can share the link with your friends. Okay, let's begin. Let's begin. I can see okay, Louis Vic, still Louis Vic. All right, so this night we are going to be solving 10 unavoidable problems on molecular shapes alongside chemical bonding. So these are problems you are not going to escape in your UTME exams. And for the 100 level students joining us tonight, the questions you're going to be solving this night are still problems you're going to see in your exams. So without further ado, let's begin from question number 1. All right, so question number 1 here says, which of the following pairs of compounds contain coordinate covalent bonds? Which of the following pairs of compounds contain coordinate covalent bonds? First of all, let's understand what a coordinate covalent bond is. A coordinate covalent bond is formed between two species. And these two species, one of the species is solely donating an electron pair, while the other one does not have an electron pair to donate. So in that case now, a particular species donates a pair, and that pair is shared between the two species. Now, looking at the options we have here, option A, we have sodium oxide. Sodium oxide is an ionic compound because you have a metal and a non-metal. We have water. Water is a covalent compound because it involves covalent bonding between hydrogen and oxygen. So option A is not going to be our correct answer. Let's go to option B. Option B, we have ammonia and ammonium ion. Now, we all know that ammonia has covalent bonds, just like you have ammonia, NH3, you have N, H, H, and H. So ammonia is made up of covalent bonds. So ammonia is not going to be our answer. Let's talk about ammonium ion. Ammonium ion is a very popular compound or a very popular species we all know exhibits coordinate covalent bond between ammonia, NH3, alongside hydrogen ion. So when these two species come together, they produce ammonium ion. So the bonding existing between ammonia and hydrogen ion is called coordinate covalent bonding. But we are not going to select option B because the question says, which of the following pairs of compounds contain coordinate covalent bonds? So since option B has ammonia, which contains purely covalent bonds, and ammonium ion, which contains coordinate covalent bonds. That's not. Let's go to option C. For option C, we have two good options here. We have water and we have H3O. Sorry, H3O plus. Now, water and H3O plus is a good, but that's not going to be our answer because water contains solely covalent bonds between oxygen and hydrogen. So that's not going to be our pair. So what about the hydronium ion? That's H3O plus. Now, hydronium ion is formed by combining water alongside hydrogen ion. So it is very clear that this pair here will give you H plus. But we are not going to select that answer because we are looking for a pair of compounds or a pair of species that exhibit coordinate covalent bonds. So the correct option here is option D. Now, option D, we have that ammonium ion NH4 plus alongside, look at this special compound here, NH3 BF3. So this is a special JAM question, is a trick. Now look at this question here. Now these two species here exhibit coordinate covalent bonds. How? Now ammonia, or the ammonium ion NH4 plus is formed by combining NH3 plus H plus to give you NH4 plus, while NH3 BF3 is formed by combining NH3 alongside F3 to give you NH3 BF3. So the correct answer to this question is option D, because in ammonium ion we have coordinate covalent bonds, and in this other compound here is a complex, we also have coordinate covalent bonds. So the correct answer is option D. Let's go to question number 2. For question number 2, it says, what is the special type of bonding present in complexes such? Look at the complex ion we have here. So what type of bond exists between this complex? Now let's break down this complex step by step. This complex here is made up of a central metal cation, which is Fe. Now the Fe you're seeing here is surrounded by 6 ligands. Those ligands are called Cn. Look at this. Look at the ligands here. How many of them do you have there? We have 6 of them. So these 6 ligands are surrounding this central metal cation. Let me draw the structure for you. It looks just like this. So there's a central metal cation here, and there are 6 ligands arranged just like this. You have Cn, 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 and you have another Cn. Now, what's so special about this type of combination is the fact that the electron pair which forms this covalent bond here, look at the covalent bonds I'm drawing, look at these covalent bonds, look at them, look at them, look at them. Now, these covalent bonds formed here are all contributed by the cyanide ions. So the cyanide ions are contributing, or let me say, they are providing the electron pair which is used to form these covalent bonds. So because of that, we call this type of bonding coordinate covalent bonding. Don't forget, coordinate covalent bonding is defined as a type of bonding in which the shared pair of electrons are brought about by just one particular species. So the other species here does not have an electron to donate. All right, so this ion here is acting as the central metal cation, while the cyanide ions are acting as the ligands because they all donate a pair of electrons to form a covalent bond. So therefore, this type of bonding is called coordinate covalent bonding. Now let's go back to the options. So the correct answer to question number 2 is option B, coordinate covalent bond. So the type of bonding that exists in complexes such as this one here is coordinate covalent bond. All right. Let's go straight to question number 3. For question number 3, the question says, which of the following will hydrogen form an ionic bond? Now let's go back to the basics. What is an ionic bond? An ionic bond is formed when there is a transfer of electrons from a metal to a non-metal. So check out all the options you have there. You have HCl. In HCl, we all know that there is no ionic bond here because we have hydrogen forming a covalent bond with chlorine. So this is a covalent bond. What about sodium hydride? Now in sodium hydride, NaH, it is very obvious that sodium here is a metal, while hydrogen is a non-metal. And we know that the type of bonding existing between metals and non-metals is ionic. So the bonding looks just like this. The sodium donates an electron pair, making it, donates an electron, making it to be positively charged, Na plus, and the hydrogen receives the electron, making it to be negatively charged. So the correct answer to question number 3 is option B, sodium hydride. Now the bonding present in ammonia is covalent, and that present in methane is also covalent. So the correct option here is option B, sodium hydride. All right, so let's get straight to question number 4. In the midst of all these questions, if you have any issues, maybe concerns, feel free to drop the concerns in the comments. I'll be willing to respond. Let's go to question number 4. For question number 4, we have the species formed when ammonia and water transfer a lone pair of electrons to hydrogen ion R dash and dash respectively. So I would like us to understand this problem before we answer. Remember, before you answer any question or attempt any problem, make sure you understand what the question is talking about. So it says, the species formed when ammonia and water transfer a lone pair of electrons to a hydrogen ion, which can also be called a proton, R dash and dash. So looking at the options, let's get right into it. So what happens when ammonia transfers a lone pair of electrons? Now check this out. This is ammonia here. You have N, you have H, you have H, and you have H. Now ammonia has a lone pair of electrons. Now let's talk about hydrogen ion. Now this is hydrogen ion here, H plus. Hydrogen ion does not have any electron. As we all know, hydrogen has one electron in the neutral state. So if you now say H plus, it's obvious that it has lost one electron. So it does not have any electrons. So what happens here is that the lone pair of electron present in the nitrogen is used to form a bond with hydrogen. And that is obviously what is happening here. And when this happens, or when this process completes, it gives us a compound which is called NH4 plus. All right, so when this donates a pair of electrons to it produces ammonium ion. Now, what about water? Water looks just like this. You have O, oxygen has two lone pairs of electrons. Okay, we have hydrogen here, have hydrogen here. All right, now when water as a molecule donates a lone pair of electrons to hydrogen ion, the same thing that happens here also happens here. So we are going to have that. We're going to produce an ion that looks just like this, H3O plus. This one is called hydronium ion. All right, so the correct answer to that question is going to be option, let's check it out. That's going to be option C. So option C says ammonium ion and hydronium ion respectively. So when ammonia transfers a lone pair of electrons to hydrogen ion, it gives us ammonium ion. And when water transfers a lone pair of electrons to hydrogen ion, it gives us hydronium ion. All right, so the correct answer is option C. The correct answer is option C. Now let's move on to the next question. We are now going to question number 5. Question number 5 says, which of the following molecules contain a polar covalent bond? Now I'm going to use this opportunity to explain to you the meaning of the term polar covalent bond. What is a polar covalent bond? A polar covalent bond, as we all know, first of all, need to understand what a covalent bond is. A covalent bond is formed when there is sharing of electrons between two species. For example, look at this. We are answering question number 5, don't forget. So for question number 5 here, hydrogen molecule H2, this is the exact structure of hydrogen molecule H2. Now for O2, it looks like this, O2. What about HCl? We have HCl. What about N2? N2 looks just like this, N2. Okay, so these are basically the bonds present in these molecules. Now let's consider a polar covalent bond. Which of these molecules here will have a polar covalent bond? Now, it's very important you understand or you understood that the type of bonding present in similar atoms is non-polar covalent. So whenever you have a similar atom forming a molecule such as H2, N2, or even O2, this is what we call a non-polar covalent bond. Why? Because the electronegativity of these two elements is equal to 0. So the En difference between similar elements is equal to 0, and because of that, they form what we call a non-polar covalent bond. So what about polar covalent bond? So which one is polar covalent bond? The polar covalent bond here will be formed by HCl. Why is the answer here HCl? Now the answer is HCl here because the electronegativity difference between hydrogen and chlorine is very large. In the periodic table, chlorine is highly electronegative compared to hydrogen. And the type of bond formed between these two types of elements here is going to be a polar covalent bond. That is why you have hydrogen here having a partial positive charge and chlorine has a partial negative charge. So our correct answer is option C. All right. Okay, I'm seeing the answer from Stanley Henry. Thank you very much. The answer is C. Now let's go to question number 6. Question number 6 says, which of the following molecules is non-polar despite having polar bonds? Now, I'm going to teach you something very special here. Now, a molecule can have polar bonds, but in the end, the molecule is what? Non-polar. Let me give you an example. Now, using question 6 as an example, let's draw the structure for water. Water is drawn like this. We all know that water is bent. It has a bent geometry. So this is water here, H, and O. So that's my water. It has 2 lone pairs on the oxygen atom. All right, so let's draw for ammonia. Ammonia, just like this, N, H, H. There's a lone pair here. All right. What about the other one? You have CO2. CO2 looks like this. You have C here, double bond to O, double bond to O. All right. That's CO2. Now, what about the other molecule there? HCl. You have H, you have Cl. All right. So, which of these molecules here is non-polar despite having polar bonds? Now, the correct answer to that question is option, which option is that? That's option C. That's the correct option. Yeah, option C is the correct answer there, CO2. Now, why is CO2 the correct answer? Now, the C to O bond is a polar bond. Why? If you look at the periodic table, let's check this out. You have hydrogen, helium, you have lithium, you have beryllium, you have boron, carbon, nitrogen, oxygen, fluorine, neon. So these are the groups here. Group 1, group 2, 3, 4, 5, 6, 7, and 8. Let's complete it. You have sodium, you have magnesium, phosphorus, sulfur, chlorine, argon. All right, so check this out. So these are the first 20 elements. So looking at these elements here, it is very, very obvious that oxygen is more negative than carbon. So in this bond here, this bond can be referred to as a polar bond. This is a polar bond. How many polar bonds are there in CO2? Now, from the structure, there are two polar bonds. So there are two C2O bonds in CO2. But in the end, CO2 as a molecule is non-polar. Now, from the concept of dipole moments, the dipole arrow goes towards oxygen, just like this. It goes towards this other oxygen, just like this, because oxygen is more negative than carbon. So in the end, the two dipoles tend to cancel out, making this molecule to have a zero dipole moment. So therefore, CO2 possesses two polar bonds, that is C2O, C2O. But in the end, the molecule has a zero dipole moment, making the molecule to be non-polar. So the correct answer to question number 6 is option C, CO2. So CO2 is one of the molecules that has polar bonds, but in the end, it is non-polar. Let's go straight to question number 7. Question number 7. If you have questions about these explanations, drop the questions in the comments. I'm going to respond to them immediately. So question number 7. For question number 7, the question says, the primary reason atoms form chemical bond is to dash. Now, in chemistry, atoms come together to form bonds, or you can say to form chemical bonds, which could be either ionic, which could be covalent, which could even be metallic. So the question is, why do atoms come together to form chemical bonds? So atoms come together to form chemical bonds because of option number C, to attain a noble gas configuration. Now, let me explain further. Now, the bonding existing between sodium and chlorine. You notice that sodium has about 11 electrons, and it is represented as 2, 8, and chlorine has about 17 electrons, which is 2, 8, and 7. Now, let's draw the structures for these two elements. Now, sodium looks just like this. You have a nucleus where and you have these shells here. So you have 2 on the K shell, you have 8 electrons on the next shell, and you have just 1 electron on the outermost shell. So sodium has an electron in its outermost shell. That makes it to be in group 1. It has 1 valence electron. What about chlorine? Chlorine looks just like this. You have the first shell, second shell, you have the last shell here. So 2 electrons here, you have 8, and you have 7 electrons on the outermost shell. Now, let's talk about the concept of chemical combinations. Now, before these two species or these two elements can come together, you notice that the sodium will have to donate an electron to chlorine. And when it does that, the chlorine is going to have 8 electrons in its outermost shell. So chlorine now transforms to 2, 8, and 8. So you have 2 electrons inside, 8 here, and 8 on the outermost shell. What about sodium? Now sodium now transforms to 2 and 8, meaning that both atoms have now come to what we call an octet configuration. So the primary reason why atoms form chemical bonds is to attain a noble gas configuration. Let's go to question number 8. For question number 8, we have the shapes of CO2, ammonia, H2O, and CH4 are respectively dash. Now, let me give you 20 seconds to attempt that question. Check through the options and guess the correct answer. Then I will help you from there. Drop the answer in the comments. You have 30 seconds. Check it out. Check through. Drop the answer in the comments. I want to see. Any answers? D. I'm seeing D from coming from Stanley Henry. Okay. I'm seeing D, linear bent, pyramidal, and tetrahedral. Okay. Nice attempt. Okay. More answers. We still have about 20 seconds. Okay. More answers. Okay. Only 3 people joined. Stanley Henry. No, don't bother about how many people joined. Just let's do the do, all right? There's no time. Okay. All right, so let me come in now. Now, looking at these molecules, okay, I'm seeing B here. B coming from pressure setback. All right. Okay, so let's check it out. So for question number 8, now CO2 molecule looks like this. Look at CO2. You have C, double bond O, double bond O. Now the shape of CO2 is linear. CO2 has a linear shape. That's for CO2. Now let's check out for the next molecule there, which is ammonia. Ammonia is drawn like this. You have N, H. I think I've drawn this today. H. You have H. There's a lone pair of electrons on the nitrogen atom. So ammonia here has a trigonal, pyramidal shape. Now let's talk about the next molecule there, which is water. Water has a very special shape. Let me draw it. Water is drawn like this. You have O, you have H, you have H. So there are 2 lone pairs of electrons on the oxygen atom. So what is the shape for this water molecule here? The answer is bent. Now some textbooks will say it is angular. It's still correct. Some will say that it is V-shaped. All these are correct. All right, so water molecule there is bent. What about the next molecule there, which is let me say CH4, that is methane, is drawn just like this. CH, you have H, H, and H. So methane is tetrahedral. So methane is tetrahedral. All right, so that's fantastic. So we can now see that the correct answer here is option B. So thank you, Precious Ekbe. Thank you, David Christopher. Thank you very much. Your answers are correct. Tetrahedral is the correct answer for methane. Now, it's very important you note that all these questions regarding molecular shapes, these are the questions you're going to be expecting in your UTME. Now, you're going to be asked about CO2. CO2 is linear. Ammonia is trigonal pyramidal. Water is bent or angular. And you also be asked about methane. All right. So let's get to the right, or let's get straight to the next problem, which is problem number 9. Let's go to problem number 9 now. So problem number 9 is asking us to, it says, the nonlinear shape of the water molecule is due to The nonlinear shape of the water molecule is due to, let's check out the correct answer to that question. So why do you think water has a nonlinear geometry? Let's go back to the geometry of water that we drew earlier today. Now, this is the geometry for water. Check this out. This is water here. Now, why do you think that water as a molecule is nonlinear? When we say that something is nonlinear, it means that that thing is not linear. So why is water bent? Let's go through the options to pick our correct answer. Option A says presence of hydrogen bonding. That's not the correct answer. B says unequal bond lengths. That's not correct. What about C? C says lone pairs of electrons on the oxygen atom. And this is ionic character of the bonds. The correct option here is option C. Water is bent because of the lone pairs of electrons on the oxygen atom. Let me give you an instance. Look at this molecule here. Look at this molecule here. This molecule here is called CO2. Look at CO2. C, O, and O. Why do you think CO2 molecule is linear in shape? It's linear in shape because of the fact that there are no lone pairs of electrons on the carbon atom. So it's free to expand or stretch out, making it to be linear. Now, let's talk about the water molecule under consideration. Water has an oxygen atom which contains two lone pairs of electrons. So these two lone pairs of electrons here tend to push the geometry molecule, making it to be bent. Now let's assume that these two lone pairs of electrons were not here. What would have been the geometry of water? It would have looked just like this. You have had O, H, and H. So water would have looked straight or linear. That is, if there were no lone pairs of electrons on the oxygen. But due to the presence of the lone pairs, the geometry becomes pushed downwards, making it to be bent. Now, this is also applicable to this special molecule called ammonia. Now, ammonia is also having that bent shape, but the shape is not really bent. It is trigonal pyramidal. Look at ammonia here. Ammonia is drawn like this. You have N, you have H, you have H, and you have H. There's a lone pair here. Because of this lone pair here, the geometry gets pushed down. It gets pushed downwards because of the lone pair of electrons here. Now, the geometry for ammonia is trigonal pyramidal. Trigonal pyramidal. So that's the geometry for ammonia. Now let's get straight to the last question for today. Now remember, I told you I'm not going to spend too much time. We're going to have a second section that will be tomorrow or next. I'm going to announce that. Then we're going to solve 10 unavoidable problems on two different topics. Today, we considered 10 unavoidable problems on molecular shapes and chemical bonding, where we talked about ionic, covalent, etc., etc. All right, let's get straight to question number 10. For question number 10, we have that which of the following molecules is non-linear in shape? So I'll be waiting for you to provide the answer in the options. Let me see the answers in the comments. Which of the following molecules is non-linear in shape? Drop the answers in the comments. Let me see. Which of the following molecules is non-linear in shape? Let me give you 10 seconds to drop the answer in the options, or drop the answers in the comments. I want to be sure you're following the class. Let me see. Okay, I'm seeing D from Stanley Henry. Let me check. D. Okay, Stanley Henry said D. Okay, let's get more options. Let's get more options. More options, more options, more options. The D coming from David Christopher. All right. I'm seeing D from David Christopher. Okay, that's fantastic. That's fantastic. That's fantastic. All right, so the correct answer is option D. You guys are correct. You nailed it. You really, really nailed it. So the correct answer here is H2O. Now, looking at the rest of the options, you notice that CO2 is linear in shape. We talked about that today. HCl is also linear in shape. H2 is linear, but water is bent. Water is bent. So let's have a review of the 10 questions we answered today. So I'm going to display them on the screen, one after the other. So any of them you don't understand, drop a comment. Let me respond to you immediately. So for question number 1, we talked about this. So this is our question number 1 here. All right, check this out. This is question number 1. It says, which of the following pairs of compounds contain coordinate covalent bonds? For those that joined late. Which of the following pairs of compounds contain coordinate covalent bonds? And the correct answer we selected from here is option D. Option D contains coordinate covalent bonds. Now, in typical exam situations, questions like this can be very tricky. Now, this question is tricky because the options are mixed. Option A is not the answer. We all know that one. Option A is not the answer. But option B now is mixed because ammonia contains covalent bonds while ammonium ion contains coordinate covalent bonds. So it's mixed. So if you are not really following up, you might miss that problem. You might miss the answer. All right, going to option C is also mixed. Water contains covalent bonds while hydronium ion contains coordinate covalent bonds. What about option? That's our correct answer because ammonium ion contains coordinate covalent bonds alongside this other complex here. All right, going to question 2. What is the special type of bonding present in complexes such as this? Now, it's very important you understood that in complex ions like this, the bonding present there is called coordinate covalent bonds. Now, the coordinate covalent bonds exist in this type of compounds because electrons which are used to form bonds are contributed by just one of the species, that is the ligand. So in case you missed this, let me illustrate again. So for that particular complex there, we have Fe, FeCN bracket 6, FeCN bracket 6. All right, so now this CN6 here shows that there are 6 ligands. Now this could be another exam question. They could be asking you, in this particular complex ion, how many ligands are there? Now, if you look at the structure of the complex ion, it's very obvious that there are 6 ligands. Look at the 6 ligands. That is 6 CN ions making up the ligands. And these 6 ligands here form what we call a coordinate covalent bond with the central metal cation, which is iron, just like this. So you see CN here, CN, 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 and CN. So all these electrons, which are used to form the 6 bonds you are seeing here, we are all contributed by CN. Now the metal cation, which is iron, does not contribute any electrons. So this type of bonding is called coordinate covalent bonding. So the correct answer to question number 2 is option B. Okay, somebody's asking a question. It says, please, I can't see clearly. Is anyone seeing this? All right. Probably it's from your device, but I think others can see this. Others can see this. All right. So we are supposed to end in 45 minutes. So we have about 7 more minutes to end. Or let me say 6 more minutes. So let's use the remaining time to do a quick recap on what we've covered so far. All right. So going to question number 3. Question number 3 says, in which of the following will hydrogen form an ionic bond? Now, we all understand that ionic bonding exists when a metal transfers an electron to a metal. So just like you have in option B, which is in sodium hydride. So in sodium hydride, we can see the existence of an ionic bond. The rest of the molecules here exhibit covalent bonding. Now let's now go straight to question number 4. For question number 4, we talked about the species formed when ammonia and water transfers a lone pair of electrons to a hydrogen ion, dash and dash. So now this is illustrating coordinate covalent bonding. Now when ammonia transfers an electron pair to hydrogen ion, it gives rise to ammonium ion. On the other hand, when water molecule transfers an electron pair to hydrogen ion, it gives rise to hydronium ion. So therefore, the correct answer here is option C. Now going to question number 5. Which of the following molecules contain a polar covalent bond? Now remember, the bond formed between atoms of the same element is basically non-polar. So option A, option B, and option D contain non-polar covalent bond. Now only option C here contains polar covalent bond. So because of that, the correct answer is option C for question number 5. Now going to question number 6. Question number 6 says, which of the molecule is non-polar despite having polar bonds? Now, I told you that a molecule can be polar, but still it can be non-polar overall. What am I trying to say? A molecule can contain polar bonds, but in the end, it is non-polar. A typical example is CO2, which is the correct answer to that question. Now, look at CO2 here. CO2 contains two polar bonds, namely the C2O bond and the C2O bond. Now, these two bonds are polar, but in the end, the molecule generally is non-polar. Why? Because the dipoles present here, they both cancel out. So the dipole go opposite directions. In other words, the dipole moment here is equal to 0. So any molecule that has a 0 dipole moment is a non-polar molecule. All right, so the correct answer to question number 6 is option C, CO2. So CO2 has polar bonds, but the molecule is non-polar. So going to question number 7. Question number 7 says, the primary reason atoms form chemical bonds is to... The correct answer here is option. The correct answer here is option C, to attain noble gas configuration. That's the main reason why atoms form bonds. All right, going to question number 8. The shapes of CO2, NH3, H2O, and CH4R, respectively. So the correct answer here is option B. CO2 is linear. NH3 has a pyramidal shape, or you can say trigonal pyramidal. And going to the next one, water is bent, and CH4 is tetrahedral. So the correct answer is option B. Now, going to question number 9, it says the nonlinear shape of the water molecule is due to... The correct answer here is option C, lone pairs on the oxygen atom. Now, the last question for today is question number 10. It says, which of the following molecules is nonlinear in shape? Now, what is nonlinear? Nonlinear means which of the following molecules is not linear? And the correct answer there is not option A, because CO2 is linear. Is not option B, because HCl is also linear. Is not option C, because H2 is linear. But it is option D, because water is not linear. Instead, water is bent. So far, so good. I would love to drop the following points for you to consider after this series, after this class. And what are the points I would love you to consider? Now, check out these points. Now, the first point I would love you to consider is today we talked about that compounds that contain coordinate covalent bonds are basically this. Now check this out. So these are examples of compounds that contain coordinate covalent bonds. Check them out. You have ammonium ion, you have hydronium ion, you have complexes like this. This is ion combining with 6 cyanide ligands. Look at copper combining with 4 ammonia ligands. All right, and look at this other complex we talked about today. So these are examples of species which contain coordinate covalent bonds. Now, let's talk about another point. Another point I would love you to also note is point number 2. The tetrahedral shape of CH4 molecule is due to what? The equal repulsion between the 4 bonding pairs. Another point I would love you to also know is that examples of van der Waals forces, that is compounds or species which contain van der Waals forces in them, these are typical exam questions you are going to see. Now, an example is iodine molecule. So iodine molecule exhibits van der Waals forces within them. Now, talking about metallic bonding exists when positive ions are surrounded by mobile electrons. Another point, you might be asked, why does water have a bent shape instead of a linear shape? We talked about that today. So water has a bent shape instead of a linear shape because of the presence of lone pairs on the oxygen atom. Now, the last point is, which of the following substances is held together by weak intermolecular forces? Now, you might see this as an exam question. Now, which of the following substances, which of the following substance is held together by weak intermolecular forces? Now, the correct answer here is going to be, it's not diamond, it's not sodium chloride, it's not copper, but the correct answer is what? Solid iodine. So solid iodine is held together by weak intermolecular forces. What are these weak intermolecular forces? The answer is van der Waals forces. All right, so that's going to be the size of our class for today. So you're going to meet again, and I'm going to drop a notification for that. And we're going to be solving 10 unavoidable problems on 2 important topics. And that'll be within this week. Between Monday and Friday, there'll be a second YouTube live. So thank you all for showing up, and I hope you enjoy the live. So I'll be seeing you in my next live. I'll be solving other problems that are connected to relevant topics for your UTME. Okay, so that will be the size of our YouTube live for today. Thank you all for showing up, and I'll see you in the next one. Have a wonderful evening. Have a wonderful night, everybody. Good night. And one more thing, I'll be dropping a video about this live, or I'm going to drop a video on this live so that you can watch the live anytime you want to. So that's all. Have a wonderful evening, everybody. Good night.